Thank you. So we had a very good two presentation. Mr. Abraham, Madam Madhura, Professor Madhura has given a lot of review about the international and where it could be used. So what I would be specifically covering will be what research CRRI has done regarding the utilization of construction demolition waste. So I have said in my title, you can see the municipal solid waste. Mr. Abraham has told now, all landfills now are having C&D waste. They are mixed up. So we have to segregate those waste. We have few landfills all over the country. Now we have to segregate that material and then we should be able to use it. So in that way, I cover both the things. The C&D specific plants are already there for segregations. So we have done some studies on that. Next. So there is the environmental impact. We already know that India is the second largest network, going to be the first largest, maybe after some time. And 70% of the emission is from the civil construction and 25% is from road sector. So the road sector is a very important contributor to the GHG emissions. So we have to go for sustainability by using C&D waste and other materials. And also the materials are not available within the economical lead, even the Northeast as well as in Bihar and other things. So alternative material waste, these local materials are very, very important to use it so that we can reduce the cost of the project. That is important. Mining, you know that already it is also creating environmental degradation. You know some of the states have banned also. So only alternative is this type of materials. So utilization of waste is very important and it will give a sustainability in the road construction. Next. So what is the challenges what we are facing here regarding, I am not specifically C&D, all materials, whatever you have, the industrial or other marginal material. Awareness is one of the factor. Nobody knows where the industry, where the waste material is generating. Only we have laboratory level studies, no field specific. If you do the laboratory and implement it, performance, you do it, then come out with guidelines, what Mr. Abraham was telling, then only people will start using it. So at present, a lot of institutes are doing laboratory level studies. We have to go more for field studies and performance oriented studies. And field implementers, they don't have time. They just do wherever what is available, they do it. If it is in the code of practice, they implement it. So we cannot blame them. They don't have time. And they have always doubts regarding the quality of roads if we use a new material like C&D, if I replace in the sub-base base, how it performs. So they don't have time to, so unless the code is there, they don't have confidence. So it's very important that we should go for the development of specification. That is the job of research institutes and academic institutes. That is there. Next. So I will just made a number of waste materials are there in the country, like fly ash is there, copper slag, steel slag, zinc waste, phosphogypsum, that is from fertilizer, chrome industries, tailings are there, marble industries, Rajasthan, foundry, you know, foundry sand is there, red mud, it's waste from aluminium industries, C&D, we have fuse now, municipal solid waste, landfills, I told you it's fuse, waste plastics, wrap. So CRRI has done a lot of studies in the lab and in the field, and we have published, contributed to IRC in development of all these guidelines. Mr. Abraham was telling about us IRCSP 121. We did some study on C&D waste also. And 132 recently, all the studies what CRRI has been put in 132, where the stakeholders can now do the work based on those guidelines. Even the municipal solid waste was also put in that. So these are some of the field applications I have indicated where we have done the performance applications. Next. Regarding the C&D waste specifically, we know that already 25 to 30 million tons is generated annually, and generally only generates about 5 million tons. So it's all dumped haphazardly. We know that it's creating pollution. So it's an alternative source of the material for the replacement of aggregates. It not only as 121, Mr. Abraham was telling, can be used as a RCA or RA, recycled aggregates, recycled concrete aggregates. We can use in the embankment, subbase, base, and other things. So there are some plants in Delhi, different plant segregation plants have been put up. Next. One I happened to visit in Burari, that Madam Professor Madhura has also indicated. It's around 2,000 ton TPD capacity. The other one, the next side is Shastri Park, where they segregate. It's a wet washing. They do the wet washing and segregation. That is very important. So in the whatever I shown in the bottom portion, some photographs are what types of aggregates comes out of the wet washing. So when you wet wash it, what happens with water, the slurry goes to a pond that becomes less than 75 micron sieve, and then we have 75 to 3 mm, 3 mm to 6 mm, 6 mm to 40 mm. So there are different types of aggregates that are generated. Next. So if you have the classification, 70% of the material, what they are saying in Shastri Park is passing 75 micron. Other one is 30% that there. 70% can be used for embankment construction. See, it's just like a soil, you can say, just like soil. So CRRI took up this study. Let us try this 70%. See, still it is just dumping. Nobody is using it. Nobody there. Even the remaining 30%, NHI, we have done some studies for sub-base base. NHI is taking up, but not fully. So even the person who is set up the plant, it's just how can you segregate when it is outside? If it goes only, they will be again segregate. So there are some problems still the field implementation. So CRRI done on 75 micron sieve. We did all the physical characterization, geotechnical characterization. Let us find its utilization in the embankment. Next. We did the grain size analysis, and just we compared with the Delhi soil. Just see, I want to replace Delhi soil for embankment as the CND waste material. If you see the characteristics of gravel, sand, clay, and everything is almost same. Absolutely, there is no problem with the grain size. Next. The Proctor compaction characteristics. Delhi soil is around 1.995 grams per cc. This is around 1.7, little bit less because of the slurry may be having these bricks portions also, a lightweight material. Otherwise, the good compaction characteristics, not so light. Next. And other thing is the shear strength characteristics. That is very important when you use for slope stability of when you use an embankment construction. The shear characteristics are quite comparable, but little bit less than the conventional soil. Next. The compressibility characteristics, CC, when you indicate it's 0.015 means it's very less compressible. That means that whenever you use this material, the settlement will be very less. That's what we want. Whenever we put in a road construction, the settlement should be less. That data indicates. And the coefficient of consolidation also indicates that the settlement will take place within the construction period only. Next. And this is the comparison. Only it's almost, if you compare Delhi soil, the local soil, what you see, and CND waste, that's almost the grain size is fine, and it's a non-plastic material, and it has got good shear strength characteristics. A little bit less than the whatever 31 degrees for Delhi soil, it is only 20 degree, and MDD is little bit less. Otherwise, these are sufficient. It can be used for road construction. Next. So we did some analysis for using it in an embankment construction with different heights. Up to 10 meter we have considered, and also considering the traffic loading that is coming up, and then what is the seismic stability. So all those things, the pavement loading, all were considered, and we considered for 1:1.5 slope, 1:2 slope, then did lot of analysis to see how much we can do next. So we did the slope stability analysis, like it's how much is the factor of safety. If you go for 4 meter, if you go up to 10 meter, all factor safeties are more than the whatever the required material. Next. Settlement analysis also we did it. So the maximum as per the codal practice is 300 mm settlement is allowed in the thing, and all are up to 8 meter. You can see that the settlement of the subsoil with this material is fine, and that's also fine. Next. And also we try to use it in subgrade. Subgrade, we, as per the ministry specification, 1.75, it should be more than that. It is little bit less. Then what we did is, we stabilized with the, mechanically stabilized with the weight 3 mm, 75 micron, whatever segregated in the C&D plast. And we are able to get use in subgrade also. By 15 to 20% you add it, you can use it in subgrade. See, subgrade is a very costly material. So with good CBR, we can get a payment less. We can use it only 15-20% add it. We can use it. So finally, we concluded that the 1:2 slope, we can go up to 10 meter with this material height. Absolutely no issue. And if you go for steeper slope, wherever you don't have space, you go up to 6 meter height. That is the conclusion what we did from the C&D conclusion. Next. Next, please. So I just conclude some of the study what we did municipal solid waste in the embankment section. This is very, very important topic apart from C&D. Say, I think what Mr. Abraham was telling, C&D are there in this also. Only thing is organic content is more. That is the thing. We should be able to segregate. We should not allow that to heap up. All old landfills are with the C&D waste. So we should extract it and use it. We did some study in Gazipur and Varanasi also. We have segregation plants. Especially they make the compost plants. And then, so we did some study. Next. And what we did is, we collected in Gazipur 200 tons of garbage, whatever from the Gazipur. Then there is a Vokla compost plant. I think Mr. Abraham is knowing there is a segregation compost plant. We use that as a segregation. Let us see what is there in the garbage. So we dumped there, allow it to dry, and use their compost plant for 1 week, only our material, what we cooked from Gazipur, and then segregated. Then we did all the proportioning and how what is the composition, what is the geotechnical characterization of the different fractions, and then we come out with some methodology for segregation also. Next. So this is the figure of the garbage we dumped there in the compost plant. Next. See, when we segregate at compost plant, you see the different sieves, passing 80, 35 mm, 80, there are different sieves are there. As sieves goes less and less, the more materials are extracted, but the amount gets reduced. You see 65 to 70 is 80 mm. If 55 to 60 is 35 mm, 44% and 27% is just like soil. You can see only thing is the color is black. That is the organic content. Next. And in this is Varanasi samples. Passing 16 mm, how the segregation is done there. Next. This is how, what we recommended is, you use the passing 16 mm fraction that composed around 44% and retained on 35 and 16 mm fractions. So together it will come to around 65 to 79% of the garbage. We can use it as an embankment. Means I am just giving juice out of the landfill. That is the only thing. I am removing all plastics, papers, the stone, bigger aggregates, everything. So next. These are all some of the geotechnical analysis. Is a gravelly material, compaction characteristics, little bit low as compared to the material. Shear strength characteristics is good. CC is medium compressible. Next. This also we did this typical stability settlement analysis. Finally, we concluded that 60 to 70% of the segregated municipal solid waste can be used for road embankment construction. 70% can be used. Absolutely no issue. Remaining 30% is your plastics, your papers, the bigger aggregates that is not crushed, that can be crushed also. So all these things that will, and some of the things out of that 30%, 20% will go as an RDF, as a refuse derived for in the waste to energy plants where they burn it getting electricity. So almost 100% of MSW can be used for this. And all leachate characteristics we tested, because finally it's very important. The leachate characteristics is very important, and it's found to be following the highway, the management rules of 2016. Leachate is fine, no heavy metals. Next. These are all the cross sections we gave. Actually earlier NH9, we can have it in the embankment and then put a cover soil. We can do like this sections. Next. This is in Varanasi we are given. Next. See, based on our recommendation, even NGT also said that Earlier, what they are doing for municipal solid waste, just protection from the slope protection of measures or some gasification from the leachate, all those things are there. But finally, they concluded that you segregate and remove the landfill. That is the instructions given. Now at our 15 machines have been put in the Gazipur to segregate it. Now they have started using, we have put in SP 132, whatever the, so that when it is come in the guideline, the people are not afraid of using it. So this is the segregation plants at Gazipur. Next. This has already been used. I went to the approach road from, there is a Kalindi Kunj. I think those who are from Delhi know that, to the Mumbai Delhi expressway. Connection is around 4-5 kilometers. They have dumped it, the material. And the segregation has been done by 30 mm and 6 mm. So they have taken 30 mm fractions there. They have compacted and finished it absolutely. No problem at all. All have been constructed. Next. This is one more material. I just want to say that, see, I say that 30% remaining will go to waste to energy plants. But waste to energy, they burn it, get the electricity. There is again creation of bottom ash and fly ash. So that also we investigated. There is one Jindal plant and 2 plants are there in Delhi. Jindal plant and then Okla, ILFS manages that. That ash also we investigated. And they are also found to be non-plastic, good compaction, so that could be used in the road construction. So all this material, C&D, municipal solid waste, and this is called incinerator residues from the waste to energy plants can be used in the road construction. Next. So I conclude that, what I see that waste material, the term itself it should go. I feel that it's a resource material. We should never say waste now. We have few problems with the conventional material. Sustainability, we are all talking. We are talking about SDGs word. So we should say that is a resource. So the terminology should change. The thing has changed. Everything can be done, can be used with the technologies are available. So the waste reduction curtailment at the source, that is very important. Marginal materials should become a alternative source. It should become a policy of the government. See, it should a policy, like Mr. Abraham was telling, it should become a policy. You use it. Whether you fail, whether the road will fail or any structure will fail. But one good thing, because of our continuous interaction with the ministry, now they have made, even in a rural road, PMGSY road, 10% of the work should be done by new technologies there, and failure is not taken. Nobody will be jailed for that. No engineer will be made. Even in the NH, I was doing the DPR in the National Highway DPR specification. They have also now started, 10% can be made. 10% of the work can be done with it. And now the contractor is forced to work, forced to use either C&D, they are used to some stabilization. New technologies, there are different terms. So in that way, how the government, they are doing it. So it should be maybe 10%, maybe tomorrow it will be 20%. So it should be raised like that. So each state's district corporation develop their own solid waste management programs is very important. Next. So I conclude that waste material protects our environment, solves the disposal. Say all industries have their own problem of disposal. And environment, we can say, cost is also reduced. So it will result in the sustainable road construction. So create wealth out of waste. Thank you.